Okay, welcome to this lecture on modeling, analysis and estimation of three-phase unbalanced power network. We have been talking about the Jacobian matrix with respect to, Jacobian matrix elements of the generator power with respect to the different solution variables. So far we have talked about the partial derivative of the generated power with respect to the voltage magnitudes and angles of all the original buses. Today we are first going to talk about the partial derivative of the generated power with respect to the internal bus voltage magnitudes and angles. So, for that let us first look at the expression of P n plus Ia, which we have already derived in the last class. So, now this is the expression of P n plus Ia. Now, in this expression, now obviously now I have this vector theta internal vector. So, now theta internal vector is actually, we know that it is theta internal 1, theta internal 2 dot 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 theta internal m transpose, and v internal vector is equal to v internal 1, v internal 2 dot 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 v internal m transpose. So, then therefore, any general term would be P del P gen I by del theta internal j, right. So, this is the general term, where for I varies from 2 to m and j would be varying from 1 to m. Please note that m is nothing but the number of generators in the system. So, then obviously now here, so then obviously I can have only two cases. One is delta P internal I by delta theta I, where both I and j are equal, and the next one is delta P internal I by delta theta internal j, where j is not equal to I. Now we know that P gen I is equal to, now we know that P gen I is equal to P n plus Ia plus P plus Ib plus P n plus Ic. So, therefore, del P gen I by del theta internal j would be equal to del P n plus Ia plus del P n plus Ib by del theta internal j plus j. So, this would be the case. Now, we have already written down the expression of P n plus Ia. Now, if we look at this expression of P n plus Ia, we can see that P n plus Ia is essentially only involves the term V internal I, theta internal I, and theta Ia, theta Ib, theta Ic, as well as VIA, VIB and VIC, correct. So then therefore I can say that p n plus I, now I can say that now p n plus I a is basically a sum function of only v internal I, theta internal I, this is v I a, v I b, v I c, theta I a, theta I b, theta I c. So then therefore del p n plus I a by del theta internal j when j is not equal to I would be 0, because del p n plus I a is not a function of any other internal bus voltage magnitude and angle. So then therefore del p n plus I a and del theta internal j when j is not equal to I would be 0, and similarly del p n plus I a by del v internal j when j is not equal to I would be equal to 0. That also would be equal to 0. So then therefore most of these elements would be 0. Now which elements will exist? Obviously del p n plus I a by del theta internal I will exist. So now therefore from here del p n plus I a by del theta internal I is given by, of course it is v internal I, and so it will only consist of this term and this term, right. This does not contain any theta internal I term, this term also does not contain any theta internal I term, and this term also, and this I mean last one also does not contain any theta internal I term. So all these, so then therefore the partial derivatives of all these terms with respect to theta internal I would be 0, only for these three they will be existing. So I can simply say that it would be v internal I, v I a, y n plus I a b c. So then therefore it would be, we can write it down in terms of a simple summation, it would be minus v internal I, let us say L A B C, then V I L, right, it would be V I L, then Y n plus I A L, then Y n plus I A L, then sine theta internal I, sine theta internal I minus theta I L minus theta I L minus alpha n plus I L. Let me write it here, minus alpha n plus I L. So this would be the expression. Right, there will be three expressions, or rather three terms, but these would be the expressions. And what would be the expression of del p n plus I a by del v internal I? This will constitute of all 6, right. So from here I will get 1 2 v internal I, 2 v internal I, 2v internal I, and then this, and then from here. So then therefore I can say from here, and so from here I can write down del Pn plus I A by del V internal I is equal to, so 2 into V internal, 2 into V internal I, and then there will be, let me collect this, Gn plus II, Gn plus Ni, Ni A, so it will be G n plus I, n plus I A plus, from here I will get one y n plus I A B, y n plus I n plus I A B cos, it will be cos 2 pi by 3 minus alpha, 2 pi by 3 minus alpha n plus I n plus I A B, then plus from here AC y n plus I n plus I AC cosine minus 2 pi by 3. So these are the terms due to V internal I squared terms. Now, but there are also another 3 terms, but that one we can write down within using a summation term, plus L is equal to A B C VIL yn plus IAL VIL yn plus IAL yn plus IAL cosine theta internal I, right, cosine theta internal I minus theta I L minus alpha n plus I L. So that would be the term. So this is the term del P n plus I A by del V internal I. Of course, this is, so there are altogether 6 components, right. So similarly, I can write down the expression of P n plus I B. So what would be the P n plus I B terms? So it is V internal I square G n plus I n plus I B B. So it would be, I mean we can simply write it from here. So let us try to write here. I will only write this term, other terms I will not write. V internal I whole square G n plus I n plus I B B plus V internal I VIA. So V internal I VIA y n plus I BA, it will be BA, then cos theta internal I minus, now because it is P n plus I B, so then therefore this theta internal, so this angle theta internal I would be replaced by theta internal I minus 2 pi by 3, that is the case. So it would be basically theta internal I minus 2 pi by 3. So it would be cosine theta internal I minus 2 pi by 3 minus theta I A minus alpha n plus I B A, right? So this would be the case, because in the case of phase A it is theta internal I, phase B internal bus angle is theta internal I minus 2 pi by 3. All the other things will be same, but these angles will change. Plus V internal I V I B y n plus I B B, then cosine theta internal I minus 2 pi by 3 minus theta I B minus alpha n plus I B B, right? Then plus V internal I VIC y n plus I BC cosine BC. So this is the, so we have come up to this. Now V internal I into V internal I n y n plus I y n plus I B A. So it would be plus V internal I whole square y n plus I n plus I B A cosine. It would be now angle for phase B minus angle for phase A. So it would be minus 2 pi by 3 minus alpha n plus I B A. Right? So that would be the case B A. And the last one would be plus V internal I whole square y n plus I BC cosine. Now theta internal I minus 2 pi by 3 minus theta internal I minus 2 pi by 3 is minus 4 pi by 3. So it is minus 4 pi by 3 minus alpha n plus I BC. So this is the expression of Pn by V. Similarly, the expression of Pn n plus IC can be written, but I am keeping it for homework. So let me again write that the expression of Pn plus IC as homework. Now, so now we have got this expression. So now again we have to find out del P n plus by IC. So now let us write down del P n plus IB by del theta internal I. So let us see how many terms has got theta internal I. only three terms, this, this and this. This doesn't contain, this doesn't contain, this doesn't contain. And if I do the partial derivative and club them together, so it turns out to be simple like this, minus L is equal to A B C V internal I V I L Y B L sine theta internal I minus 2 pi by 3 minus theta I L minus alpha n plus I B L. So that is the case. So this is the expression of this. And then lastly, del P n plus by B delta V internal I would be del P del V internal I. So again there will be two terms corresponding to V internal square. Sorry, there will be three terms corresponding to V internal square. So 2 V internal I. So 2 V internal I. First term would be due to this Jn plus I n plus I BB. BB. Then Y n plus I BA. Then plus Y n plus I n plus I BA cosine minus 2 pi by 3 minus alpha n plus I n plus I BA. That is the case. And then plus Y n plus I BC, then plus Y n plus I n plus I BC cosine, it would be minus 4 pi by 3 minus 4 pi by 3 minus alpha n plus I n plus I BC, right, plus other three terms would be, we can simply take them by means of an summation terms. L is equal to A B C, then it would be VIL Y n plus I BL, then cosine internal I minus 2 pi by 3 minus theta IL minus alpha n plus II BL minus alpha n plus I BL. So this is the expression for Pn plus IB delta V internal I. Correct. So similarly, we can write down the expression of Pn plus I A, sorry, similarly we can write down find the expressions of del P n plus I C by del theta internal I and del P n plus I C by del V internal I. But again, as before, I am keeping them as homework. Right. So once we have got these three terms, so we have already derived the terms del P n plus I A by delta theta internal I and del P n plus I A delta V internal I. We have already derived this. We have also derived these terms del P n plus I B by delta theta internal I and del P n plus I B delta V internal I. Similarly, we can find out del P n plus I C delta theta internal I and del P n plus I C delta V internal I. Once we find them, just by using this relation, I can find out del P gen I by delta theta internal I, right, that we can find out. So once we have this, so then therefore we can have del P gen I by delta theta internal I is nothing but del P n plus I A by delta theta internal I plus del P n plus I B delta theta internal I plus del P n plus I C by delta theta internal I. Similarly, I can find out del P gen I by del V internal I is equal to so with this we can find out the partial derivatives of generated power at bus I with respect to all the internal voltage angles and magnitudes. So with this we can complete the derivation of the Jacobian matrix. The last four Jacobian matrices which actually remain to be derived are essentially for the sum in voltage with respect to all the decision variables, which we will take care in the next lecture. Thank you.